Good morning. It's January 28th, and this is your daily brief in science. Here's everything you need to know. A human case of bird flu, specifically H5N1, has been confirmed in England, marking the first reported human infection since May 2023. The infected individual is currently in isolation, and health authorities are actively conducting contact tracing to identify anyone who may have been exposed. All individuals who had contact with the infected person have been traced, and those deemed at highest risk have been offered antiviral treatment. Experts, including Professor Alistair Ward, have stated that the overall risk to the general public remains very low. Wendy Barclay, a professor of infectious diseases, emphasized that this case was not unexpected, given the high number of H5N1 infections reported in poultry. UK Chief Veterinary Officer Christine Middlemiss noted an increase in avian flu cases among both commercial and backyard birds in England. In response to the ongoing outbreaks of H5N1, the UK's Department for Environment, Food and Rural Affairs has expanded the avian flu prevention zone to encompass all of England. A national avian influenza prevention zone has been implemented, mandating strict biosecurity measures for all bird keepers. Concerns remain regarding the potential for the H5N1 strain to mutate and lead to a pandemic, although human-to-human transmission is still considered unlikely. A recent study analyzing gene sequences of various H5 subtypes revealed that viral evolution occurs more rapidly in vaccinated poultry populations. The bird flu has spread globally in recent years, leading to the culling of hundreds of millions of poultry and affecting various mammal species. While severe complications like pneumonia can develop, early treatment with antiviral medicine is crucial for preventing serious outcomes. A new technology, CRACO, developed by CSYRO for the ASKAP radio telescope, is making waves in the field of astronomy. This innovative system is designed to detect fast radio bursts and other astronomical phenomena by analyzing signals from space. Led by Dr. Andy Wang from Curtin University, the research team reports that CRACO has already surpassed expectations, identifying more signals than initially predicted, particularly in the area of fast radio bursts. During its initial tests, CRACO successfully detected 2 fast radio bursts and 2 neutron stars. Since then, it has identified over 20 additional fast radio bursts, demonstrating its significant potential. Operating at an impressive rate of 100 detections per second, CRACO plans to increase this capability to 1,000 detections per second, enhancing the speed of astronomical research dramatically. The system is designed to alert researchers in real time upon detecting anomalies, allowing for timely follow-up observations and analyses of cosmic events. Soon, CRACO will be accessible to astronomers worldwide through CSYRO's Australia Telescope National Facility, promoting collaborative research efforts on an international scale. The development of CRACO was a collaborative effort involving CSIRO and various Australian and international researchers, with partial funding from the Australian Research Council. Dr. Wang's team is also working to expand CRACO's capabilities to explore long-period transients, mysterious objects within our galaxy. Understanding the source galaxies of fast radio bursts is crucial for measuring distances in the universe and enhancing our knowledge of cosmic phenomena. Keith Bannister, who developed CRACO, compared the data processing involved to searching for a single 5-cent coin on a beach, emphasizing the vast scale of data the system manages. The initial findings from CRACO were published on January 28, 2025, in the Publications of the Astronomical Society of Australia, marking a significant milestone in astronomical research. CRACO is approximately 100 times more effective than previous systems at processing large volumes of radio data, significantly increasing the sensitivity of the telescope. A newly discovered super-Earth, known as HD 20794d, has sparked interest among scientists as it may support conditions suitable for alien life. Located approximately 19.7 light-years from Earth, this planet was identified by an international team of researchers, including experts from the University of Geneva and the University of Oxford. Their findings were published in the journal Astronomy and Astrophysics after 2 decades of meticulous observations. HD 20794d orbits a G-type star, similar to our Sun, making it a close neighbor in cosmic terms. This proximity facilitates its study due to the star's brightness. The planet resides in the habitable zone of its star, which raises the possibility of liquid water existing on its surface. However, its elliptical orbit introduces complexities regarding this potential. With a mass 6 times that of Earth, HD 20794d is classified as a super-Earth and is believed to have a solid, rocky surface. Dr. Michael Crétinier, a key contributor to the discovery, expressed enthusiasm about the potential for future missions to investigate the planet's atmosphere for signs of life. The detection of HD 20794d utilized extensive data analysis through a noise reduction algorithm called YARARA, developed by Crétinier to interpret signals from the high-accuracy radial velocity planet searcher spectrograph. Future missions, including the James Webb Space Telescope and the Nancy Grace Roman Space Telescope, are anticipated to enhance observations of exoplanets like HD 20794d and search for biosignatures. Researchers believe that studying this planet could yield valuable insights into planetary habitability and the potential for life beyond Earth. The unusual brightness and proximity of HD 20794's star make it a prime candidate for future telescopes to directly observe the atmospheres of its orbiting planets. Since the first confirmed exoplanet was discovered in 1995, astronomers have identified around 7,000 exoplanets, with billions more still to be discovered, fueling the ongoing exploration of whether we are alone in the universe. A significant advancement in breast cancer treatment has arrived with the FDA's recent approval of Enhertu, a drug developed by AstraZeneca and Daiichi Sankyo. This approval targets adult patients suffering from unresectable or metastatic hormone receptor-positive, HER2-low, or HER2 ultra-low breast cancer, allowing for earlier treatment options. According to AstraZeneca's Dave Fredrickson, this decision enhances access for patients with HER2 expressing metastatic breast cancer, marking a vital step forward in treatment accessibility. Clinical trials have demonstrated that Enhertu offers a 36% reduction in the risk of disease progression or death when compared to traditional chemotherapy, with an impressive objective response rate exceeding 60%. The FDA's approval was primarily based on the results from the DESTINY-Breast06 Phase 3 trial, which revealed a median progression-free survival of 13.2 months for Enhertu, significantly better than the 8.1 months observed with chemotherapy. This expansion of treatment options is crucial for patients who have already progressed on one or more endocrine therapies. However, it's important to note that Enhertu comes with safety warnings, including potential interstitial lung disease and embryo-fetal toxicity, which necessitate close monitoring of patients. Concerns about safety have been raised as well, with TDXD showing a higher incidence of specific adverse events, such as nausea and fatigue, compared to traditional chemotherapy. Prior to this approval, Enhertu had already been authorized in over 75 countries for patients with HER2-low metastatic breast cancer who had received previous systemic therapy. The approval is also being supported by ongoing regulatory applications in the EU, Japan, and other regions, based on the promising results from the DESTINY-Breast06 trial. Notably, approximately 85 to 90% of patients with HR-positive, HER2-negative metastatic breast cancer exhibit actionable HER2 expression levels, broadening the eligible patient group significantly. Dr. Aditya Bardia, a trial investigator, emphasized that Enhertu could represent a new standard of care, especially following poor outcomes associated with chemotherapy after endocrine therapy failure. Enhertu is a HER2-directed antibody-drug conjugate, showcasing the versatility of modern oncology treatments, and is indicated for various breast cancer types, as well as HER2-mutant non-small cell lung cancer. A remarkable discovery in Denmark has shed light on the diets of ancient marine life. Amateur fossil hunter Peter Bennick unearthed a piece of fossilized vomit dating back 66 million years on the cliffs of Stavens, a UNESCO World Heritage Site. Initially, Bennick found unusual fragments within a piece of chalk, which were later identified as remnants of sea lilies after examination at a museum. experts confirmed that the vomit contains remains from at least 2 different species of sea lily, suggesting it was likely regurgitated by a fish after consuming them. Paleontologist Jesper Milan remarked that while sea lilies are not particularly nutritious, consisting mainly of calcareous plates with minimal soft parts, this discovery indicates that certain fish species consumed them during the Cretaceous period. Milan described the find as truly unusual and valuable for understanding the prehistoric food chain, emphasizing its importance in reconstructing past ecosystems. The Museum of East Zealand highlighted that such findings provide crucial insights into the diets of prehistoric animals and predator-prey relationships. The cliffs of Stevens are historically significant, as they offer evidence of the Chicxulub meteorite impact, which is believed to have contributed to the extinction of dinosaurs around 65 million years ago. Previous studies have investigated ancient regurgitated remains and fossils to explore dietary relationships among prehistoric species, with similar discoveries made in Poland and Utah. In a related finding, paleontologists in the United States discovered fossilized vomit from a beaverfish in 2022, revealing dietary information about prehistoric species like small frogs and salamanders. The fossilized vomit was presented by the Museum of East Zealand on January 27, 2025, and consists of pieces of crinoids, a type of marine animal resembling plants. Bennick's initiative to bring the fragments to a museum for analysis has significantly benefited scientific research, allowing for a deeper understanding of ancient marine ecosystems. Overall, this discovery enhances our knowledge of the dietary habits of ancient fish and contributes to our understanding of ecological dynamics during the Cretaceous period. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.